can you tell if an equation is a quadratic or not? So we're going to work 13 through 16 together and see if we can get some strategies to be able to determine that. So first of all, if I'm given an equation y is equal to the quantity x plus 3 squared minus x squared, the best thing to do is to go ahead and simplify the equation and then go ahead and look at its final form to see if it fits ax squared plus bx plus c. Remember, a quadratic is always in the form y is equal to ax squared plus bx plus c. So if we can get this expression to look like this, then we know we've got ourselves a quadratic equation. So this is the same as x plus 3 times x plus 3 minus x squared. Well, if I multiply x times x, I get x squared. If I multiply x times 3, I get 3x. And then if I multiply 3 times x, I get another 3x. And if I multiply 3 times 3, I get 9. And then, of course, I got the minus x squared at the end. Alright, so let's combine our like terms here. So now I have y is equal to x squared plus 6x plus 9 minus x squared. Well, now I'm going to combine those like terms. X squared minus x squared equals 0. So we're left with y is equal to 6x plus 9. Well, guess what, guys? This does not fit the form y equals ax squared plus bx plus c, because in this case a is equal to 0. Alright, a is equal to 0. Therefore, equation is not a quadratic. Okay? Alright, so that's 13. Going to 14, here I'm given y is equal to x plus 3 times x minus 5. I want to show you an alternative way. We just did one form of multiplication with two sets of binomials multiplied together. I want to show you an alternate way that I use that I find very nice in terms of keeping things organized. If I take the first expression, x plus 3, and I multiply it by x minus 5, now watch what I do. This is almost like long multiplication. So I'm going to go negative 5 times 3 gives me negative 15. Then I'm going to go negative 5 times x is negative 5x. Now I'm going to move one term over and again multiply both the top terms by now this term. So I go x times 3 is a positive 3x. Notice I put that in the same column as the negative 5x. And then I go x times x, which gives me x squared. Now all I have to do is add my columns. So I go x squared, negative 5x plus 3x is negative 2x. And then my third column is negative 15. So our final equation is y is equal to x squared minus 2x minus 15. And in this case, it does fit the form. Now, ax squared plus bx plus c, my a is 1. Notice I can put a 1 there and it doesn't change anything. My b is negative 2, and my c is negative 15. Okay? So, there is number 14, 13 and 14.